Hello everyone, this is section 5.4, differentiation of exponential functions. First thing, all an exponential function is a function in which the variable is in the exponent. So if you look here on the left, y equal e to the x is your variable, it's literally in the exponent. Or it could be more generic, e raised to something with x in it, so g of x could be, anything, x squared plus 5, 3 minus 5x, whatever it is. It's something with x in it. So these are examples of exponential functions. E is the Euler number, roughly 2.71828, named after Euler, spelled E-U-L-E-R. You should have an E button on your calculator, so you may want to familiarize yourself with it. We're just concerned with doing derivatives here. So I actually want to start on the right here and use this more generic form of a basic exponential function and create the formula. Once we have the formula, we can just use it. You won't have to recreate this, but I want to show you where it comes from. So first thing, I want to get rid of this exponent. And we learned something in algebra. If we're dealing with logs, then we can exchange exponents and coefficients, interchange them if you will. So in other words, that rule was this: if I had like log of x to the r, that was the same thing as r log x. So notice the exponent and coefficient are interchanged here. These are equivalent expressions though. If you typed them in a calculator, it'd be the same value. So if I want to use this rule, I need the log here. So if I do the log of one side, I got to do the log of the other. Okay, so that gets the logs in there. So now I can take g of x and move it out front just like we did with r in this formula here. Okay, and let's clean it up a little bit. The log of e is actually equal to 1. You can verify that in your calculator if you like, but g of x times 1 is just g of x. So let's rewrite this as just the log of y equals g of x. Okay, the last section we covered was implicit differentiation. We did implicit differentiation basically when we had a function where y wasn't by itself on one side. And that's basically what we have here. We have the log of y on the left, but not just y. So we would use implicit differentiation here. The derivative of the log of y is 1 over y. And remember, that's a y you took the derivative of, so we say dy dx behind that. On the right side, you have g of x, so the derivative of that would be g prime of x. We don't need dy dx there because we did the derivative of x, not y. Okay, the next thing we did in implicit differentiation was to get dy dx by itself. So in this case, we can just multiply each side by y, and we've got dy dx by itself. Okay. Now there's nothing wrong with this formula here, but let's write it so that we're only having to think about one variable. In other words, if you go back to the beginning, y equaled e to the gx, we could substitute that in down here at the bottom and rewrite this as dy dx equals e to the gx multiplied by g prime of x. Okay. In other words, it's saying rewrite the function as you have it. E to the gx is what we started with. We're rewriting e to the gx here. And then we're multiplying times the derivative of the exponent. G prime of x is the derivative of g of x. Okay. So you'll need to know that rule. That's the exponential derivative rule. As an aside, I want to go back to the left side here. If you have just e to the x and you apply this rule, basically what's going to happen is you'll get dy over dx equals e to the x times the derivative of the exponent. Well, the exponent's x. The derivative of x is just 1. So anything times 1 is itself. Okay. This is a special function. e to the x is the only function in which its derivative is exactly the same as the original function. The derivative of e to the x is e to the x. Okay. Let's look at some examples. So number 1 here. Find the first derivative of the function y equal 5x to the fourth minus 4 e to the x. So we have two separate terms here. There's a minus sign in between them. So just do the derivative of each term. Your first term is just a power rule. So 5 times 4 is 20, so this will be 20x cubed. Your second term, minus 4 e to the x, well, minus 4 is a coefficient, but we have that e to the x there. So we're doing the derivative of e to the x, like we did here on the left side of the page. Derivative of e to the x was e to the x. Nothing to simplify. We're good. Alright, and the next problem, negative 5 e to the 1/2 x to the fifth minus 9. It's all one term. There's no other variable in here. X is just written the one time. So we have something in the form e raised to something with x. In other words, we have e raised to gx here. So we'll have to go back and use the more generic form of the rule that we did there on the right. Derivative of e to the x is, excuse me, the derivative of e to the gx is e to the gx times g prime of x. So let's do that. Okay, so we should rewrite it just as it is, not changing anything. And then multiply times the derivative of the exponent. So your exponent there was 1/2 x to the fifth minus 9. So back earlier in the semester, if we said take the derivative of that, that's just a power rule problem. It'd be 5/2 x to the fourth, derivative of negative 9 would be 0. So we'll have 5/2 x to the fourth here. And you can leave it just like that. That's perfectly okay. If you want to simplify for whatever reason, that's okay too. Hawks will take unsimplified, but it's your choice. 5 times 5/2 would be, we have negative 25/2. Have x to the fourth. I always write e last because usually I can avoid parentheses if I write it at the end there. So there we go. All right, number 3. Notice this is really the same kind of thing we just did in number 2, but it's actually simpler because you don't have the fractional exponent like you did up here. So it's, again, the exact same thing. So the derivative of 4e to the 5x squared is going to be, rewrite it, 5x squared plus 3, excuse me, and multiply times the derivative of the exponent. So the derivative of 5x squared is 10x, derivative of 3 is 0, so it's gone. So again, this is an acceptable answer. Hawks will accept it. Or if you want to multiply out, you can go ahead and do that. 4 times 10 is 40. Still have that x, e to the 5x squared plus 3. So either one's acceptable. All right, so that's the basic rule for exponential derivatives. It's not a hard rule. In algebra, exponentials was probably one of the harder topics. But actually, what we do with exponentials here in calculus is not that bad. I'm just taking the derivatives of them. All it is rewrite it, multiply times the derivative of the exponent. After this, they'll start mixing in some other derivative rules. So for example, something like this. Negative 8x to the fourth times e to the x. So if you look at this, notice there's no plus or minus sign in between x to the fourth and e there. So in other words, this is all one term. It's negative 8x to the fourth multiplied by e to the x. It's all multiplication. It's all one term. So I have something with x here, and I have something with x here. I'm multiplying two things with x. We did that a long time ago, back in section 3.1. That was the product rule. So we'd call negative 8x to the fourth first, and we'd call e to the x second. The product rule was first times the derivative of the second, plus the second times the derivative of the first. First, d second, plus second, d first. Okay, so let's fill into that format. First is negative 8x to the fourth. Okay. Derivative of second, so this is where you're doing the derivative of e to the x. Well, remember, the derivative of e to the x is e to the x. So it doesn't really look like you're doing a derivative there, but you are. It's just, that's a special function. E to the x is the only function in which the derivative is the same thing. The derivative being e to the x. Alright, keep going, plus second, which is e to the x, times d first. So we need the derivative of negative 8x to the fourth, which will be negative 32 x cubed. And again, you don't have to simplify things on Hawks. That's the way we have it set up. So if you want to type it all in like that, perfectly okay. I like to get rid of parentheses just because it's cleaner looking. Notice the parentheses in the first term over here really aren't doing anything. So we can just rewrite that as negative 8x to the fourth e to the x. And then for the second term over here, it's just kind of written backwards from what the first term was. E's at the end over here in the first term. It's at the beginning here. We'll just flip it over. Write the minus 32 x cubed first. And write the e to the x at the end. So there we go. We can write it without all those parentheses. It just looks cleaner that way. And one last problem, okay, which again is similar to question 4, but it's not just e to the x this time. So we have 5x to the fourth times e to the 7 minus 3x to the fifth. So notice this just isn't e to the x. So you have to use that more generic form of the exponential derivative to get the derivative there. But we'll start off the same way. 5x to the fourth can be first. E to the 7 minus 3x to the fifth can be second. Your derivative will be, again, first, derivative second, plus second, derivative first. Okay, so let's fill in there. First is 5x to the fourth. Now the derivative of the second, so this is exponential, we rewrite it, e to the 7 minus 3x to the fifth. Excuse me. And then multiply times the derivative of the exponent. Okay, so this is like e to the gx. We need to multiply by g prime of x. So that's the derivative of 7 minus 3x to the fifth. Derivative of 7 is 0. It's gone. Derivative of negative 3x to the fifth will be negative 15x to the fourth. Okay. All right. Let me rewrite that because... All right. Keep going. Plus second e to the 7 minus 3x to the fifth times d first. The derivative of 5x to the fourth is 20x cubed. And once again, if you want to leave it like that, it's okay. I just don't like it because of all the parentheses. It just looks ugly. So I'm going to go ahead and multiply out. So 5 times negative 15 is negative 75. X to the fourth times x to the fourth is x to the eighth. Have the e at the end, e to the 7 minus 3x to the fifth. And then over here in the second term, just flip it over, write the e at the end. So plus 20 x cubed e to the 7 minus 3x to the 5th. And that's it for this section.